Here's example 7 of a truth table for lesson 8D, our logic unit. Here's the problem that we'll do. So we have to break it apart and take care of this piece first that I'm highlighting in the green. This is considered an equivalence. So that's the if and only if statements. So I'm going to go ahead and put that in my column 3. And we'll refer back to our formula packet. Here is our rule for equivalence. P and Q should be the same for this to be true. So if we go back to the propositions P and Q, both of them are true. They're both the same. And then that last row, both of them are the same. All right, so let's go back. So to be true, both have to be the same. So these are both the same, so the truth value is true. Both of these are the same, so it is true. The other two then are considered false. All right, I'm going to erase that. Now we're going to look at the next symbol. This is not P, so it's considered a negation of P, so the opposite of P. So that'll be in our 4th column, so negation. So we're going to do the opposite of these truth values. So if this is true, the opposite would be false. This one's true, the opposite is false. This one's false, the opposite is true. This is false, so the opposite is true. All right. Now we're going to put it together, what we have here in the blue. So you do your equivalence. The notation in between them, the symbol in between them is a conjunction, an and then not P. This is a conjunction. So for conjunctions, going back to our formula sheet, for conjunctions, has the word and in between them, the rule is both of them must be true in order for it to be true. So the rest will all be false. So we're going to be looking at the green column and the red column. We want them both to be true. So the only one that is both true is row 4. All the rest are going to be considered false values. So here is your final answer for your truth values for that question